students, in today's session we are going to discuss about pin diagram of 8085 microprocessor. At the end of the class we will be able to understand function of each pin available in 8085 microprocessor. As you seen in this figure, there is a 40 pins available in 8085 microprocessor. This arrow direction is input pin and this one is output pin and this one is bidirection. Now let's start from the pin number 1 and 2, that is X1 and X2. These are also called crystal oscillator input pins. 8085 can generate clock sign internally. To generate clock signal, Intel 8085 requires external input X1, X2. That means X1, X2 is a crystal oscillator connected as these two pins. That is like this one is the crystal oscillator. This frequency is internally divided by 2. Therefore, to operate a system at 3 MHz, the crystal oscillator should have the frequency 6 MHz. An 8085 microprocessor operates at a 3 MHz frequency. Now reset in and reset out, that is pin number 36 and pin number 3. Reset out and reset in. Reset in, it is used to reset the microprocessor. It is active low signal. When the signal on this pin is low for at least 3 clocking cycle, it forces the microprocessor to reset itself. Reset is the active low signal, means in bar. Bar means it is an active low signal. 1 bar equal to 0. It is active when this pin is low. It resets the program counter to 0. The microprocessor is held in reset condition as long as reset is applied. Suppose there is a microprocessor. In microprocessor there is a program counter. Program counter having the address of the memory 2000. Suppose program counter having the address 2000, after receiving the reset in, program counter initialized by the 00, that means it is in reset condition. Resetting the microprocessor means clearing the program counter, PC and instruction register IR, disabling all interrupt except trap, disabling the SOD pin. All the buses data address control are tri-stated. Give high output to reset out pin. Now reset out. It is used to reset the peripheral and the other IC on the circuit. It is an output signal because arrow is going towards the input output devices. It is an active high signal. The output on this pin goes high when reset is given low. The output remains high as long as reset is kept now low. Microprocessor and input output device. Suppose peripheral devices is connected to the microprocessor. This signal indicates that the microprocessor is being reset. This signal is used to reset all the connected devices. When the microprocessor is reset, means connected to the microprocessor, every device is being reset. Now SID and SOD, that is pin number 4 and 5. SID, serial input data. Microprocessor uses this pin to receive serial data on this pin from some input devices which is sending the data serially. Means SID stands for serial input data. The 8085 microprocessor accept the data or input serially. SOD stands for serial output data. The 8085 microprocessor display the output serially. Serial means serial. That is, at a time only one data is transmitted, either 1 or 0. Interrupts mean, it means interrupting the normal execution of the program. When microprocessor receives interrupt signal, it discontinues whatever it was executing. It start executing new program indicated by the interrupt signal. Interrupt signal are generated by the external peripheral devices. After execution of the new program, microprocessor goes back to the previous program. Here is the microprocessor which is connected to the input-output device. Suppose input-output device says request the microprocessor to access the control or address bus or any other program to execute. At that time microprocessor respond the peripheral devices. There is a 5 hardware interrupts in 8085 microprocessor, that is TRAP, RST 7.5, RST 6.5, RST 5.5 and INTR. Classification of interrupts: maskable and non-maskable, vector, non-vector, edge trigger, level trigger and priority based interrupt. What is maskable interrupt? Maskable interrupt are interrupts which can be enabled or disabled. Means maskable interrupt which is affected by any other input signal. Here is the 4 type of maskable interrupt, that is RST 7.5, RST 6.5, RST 5.5 and INTR. Non-maskable interrupt. The interrupt which are always in enable mode or called non-maskable. That means that is not affected by any other input signal. Trap is a non-maskable interrupts. Vector interrupt. The interrupt which have fixed memory location or transfer of control from normal execution. Each vector interrupt points to the particular memory location. Means vector interrupts means which is having a particular address in memory, that is called vector interrupt. RST 7.5, RST 6.5, RST 5.5 and TRAP is the vector interrupt. Address of this vector interrupt is calculated by multiplying the RST value with 008. RST 7.5 has the RST value is 7.5 multiplied by the 008, that is 0036 and so on. Non-vector interrupt. The interrupt which don't have fixed memory location for transfer of control from normal execution. The address of the memory location is sent along with the interrupt. Means which don't have a fixed memory location. They have no memory location, fixed memory location. It's called non-vector interrupt. INTR is a non-vector interrupt. Is trigger interrupt. The interrupt which are triggered at leading or trailing edge are called the edge trigger interrupt. RST 7.5 is an edge trigger interrupt. It is triggered during the leading positive edge. Suppose this is the pulses. This one is the positive edge triggering. Level trigger. The interrupt which are triggered at high or low level are called the level trigger interrupt. RST 6.5, 5.5 and INTR. Trap is edge and level trigger interrupt. This is called the level trigger interrupt. Level triggering. Priority based interrupt. Whenever there exists a simultaneous request at two or more pin, then the pin with higher priority is selected by the microprocessor. Priority is considered only when there are simultaneous requests. Suppose peripheral devices interrupted the microprocessor to perform another operation. At the time, microprocessor responses according to the priority in which pin request is received. Priority is given below. The trap has the highest priority, then RST 7.5, then RST 6.5, RST 5.5, and finally INTR is the lowest priority. Then what is trap? Trap is a non-maskable interrupt. It has the highest priority. It can be disabled. It is both edge and level triggering. A trap signal must go from low to high and must remain high for a certain period of time. Trap is usually used for power failure and emergency shut off. Trap is a non-maskable interrupt means that signal is not affected by any other input signal which has the highest priority. Which has the highest priority, that means the 8085 microprocessor responds first to the trap signal. RST 7.5, it is maskable interrupt. That means it is affected by any other input signal. It has the second highest priority after trap. RST 7.5 has the second highest priority. It is positive edge trigger only. That means positive edge triggering. The internal flip-flop is triggered by the rising edge. The flip-flop remains high until it is cleared by reset in. RST 6.5. It is maskable, that means it is affected by any other input signal. It has the third highest priority. After RST 7.5, it is the third highest priority. RST 5.5, it is maskable, that means it is affected by any other input signal. It has the fourth highest priority after RST 6.5. It also level trigger, then pin has to be held high for a specific period of time. This interrupt is it is a maskable interrupt. It has the lowest priority. It is also level triggering. It is a general purpose interrupt. By general purpose we mean that it can be used to vector microprocessor to any specific subroutine having any address. It is affected by any other input signal. It has the lowest priority among all the interrupt. INTA. INTA stands for interrupt acknowledge. It is an outgoing signal. Arrow is towards the input-output devices or peripheral devices. It is an active low signal because there is a bar on INTA signal. It is active when this pin is 0. So it is called active low signal. Low output on this pin indicates that microprocessor has acknowledges the INTR request. Here is the microprocessor and there is the IO devices. Whenever microprocessor is received interrupt signal either in trap RST 7.5 or 6.5 or 5.5 or INTR. After receiving interrupt signal, microprocessor has to acknowledge the input output devices that microprocessor has received the interrupt signal. So microprocessor acknowledges the peripheral devices through the INTA bar. This INTA signal or interrupt acknowledgement sent by the microprocessor after INTR is received. Pin number 19 to 12, AD0 to AD7. This is bidirectional. This pin serves the dual purpose of transmitting lower order address and data byte. During first clock cycle, this pin acts as a lower half of the address. In remaining clock cycle, this pin acts as a data bus. The separation of lower order address and data is done by the address latch. These are the multiplex address and data. Multiplex address and data means there is a address bus A0 to A7 and data bus D0 to D7. These buses are combined AD0 to AD7. This technique is called multiplexing. The 8 most significant bits of this address are transmitted by A8 to A15. The 8 LSB of the memory address or IO address are transmitted by the AD0 to AD7. The address and data bus transmit data and address at different time. That means at a particular moment it transfers either the data or address. Thus the address and data bus operate in time sharing mode. This technique is known as multiplexing. A8 to A15. This one is the higher order address bus. This pin carry the higher order of address bus. The address is sent from the microprocessor to memory. So it is bidirectional because address is sent from the microprocessor to memory only in one direction, that is microprocessor to memory. So it is called as unidirectional. In this, when an address is sent by the microprocessor, all the device connected to the microprocessor receives their address through the address bus, but only the device response which has received chip enable signal from the CPU. ALE, address latch enable. It is used to enable address latch. It indicates whether bus function as address bus or data bus. That means it is an output signal because AL is towards the peripheral devices or towards the output. It is an output signal used to give information of AD0 to AD7. When we go out to separate it, that is A0 to A7 and D0 to D7, because at a time either data is transfer or address is transfer. To know whether the data is transmitted or address is transmitted, ALE give the information of AD0 to AD7. When AL is set to 1, when AL is set to 1. It indicates AD0 to AD7 are address. When AL is set to 0, it indicates AD0 to AD7 are data. So AL gives the information of AD0 to AD7 which are multiplexed. Now S0 and S1 pin, that is pin number 29 and pin number 33. S0 and S1 are called status pin. They tell the current operation is in progress in 8085 microprocessor. Or S0 and S1 are the status signal which are sent by the microprocessor for various operations. There is a table operation of the microprocessor. If S0 S1 set to 0 0, then there is a halt operation. If S0 S1 is 0 1, then there is a write operation. If S0 S1 is 1 0, then read operation. If S0 and S1 both are 1 1, then there is a fetch operation is taking place. IO/M bar, it represents input and output operation. This pin tells whether input, output or memory operation is being performed. That means microprocessor issues IO/M bar signal to indicate whether it wants to communicate with input output devices or memory. Here is the microprocessor, here is the input output devices and memory. When this signal is generated to indicate whether it wants to communicate with the input output devices or memory. If IO/M bar signal is high, then microprocessor wants to communicate with the input devices. When IO/M bar is low, then microprocessor wants to communicate with the memory. RD bar. RD bar stands for read operation. It is an active low signal because RD bar this indicates it is an active low signal. When this is 0, at that time it is activated. It is a control signal used for read operation either from memory or input output devices. Means there is a microprocessor or input output devices. If microprocessor wants to take data from the IO devices, then it is read operation. When it is low, the selected memory or input output devices, is to be read. Write operation. It stands for write operation. WR bar is. It is an active low signal because there is a bar. WR bar. It is active when this pin is low or 0. Microprocessor or memory or input output device. When data is going through microprocessor to memory or input output devices, this is the write operation WR bar. When WR bar is low, the data on the data bus is to be written into the selected memory or input output location. Ready pin. This pin is used to synchronize slower peripheral the microprocessor to enter into wet state. The microprocessor remain in wet state until the input at this pin goes high. This ready signal is used by the microprocessor to sense whether a peripheral device is ready to transfer data or not. When ready pin is high, means ready is set to 1 or it is high, then peripheral devices are ready to transfer data to the microprocessor. If ready pin is low, then peripheral devices is not ready to transfer the data. Hold pin is used to request the microprocessor for DMA transfer. A high signal on this pin is a request to microprocessor to relinquish the hold on buses. This request is sent by the DMA controller. There is microprocessor and there is input output devices. Microprocessor input output devices are directly not connected. To connect this, there is a DMA controller is available 82 or 8257. If input output devices wants to access the control address control, then it is go to the DMA and DMA request the microprocessor at the hold pin that input output devices wants to access the address control. Then microprocessor inform the DMA controller through the HLDA pin hold acknowledge. HLDA stands for hold. Processor uses this pin to acknowledge the receipt of hold signal, as I told in hold pin. When HLDA signal goes high, address bus, data bus, read, write, IO/ember pin are tri-stated. This means they are cut off from external environment. VSS and VCC. VCC is the supply voltage. This pin indicate the power supply to microprocessor, that is 5 volt. And VSS is the ground signal. If there is excessive power supply, then it is passed to the ground. And there is a clock out. It is a clock output for user. Its frequency is same as at which the processor operates. Thank you.